All right, so today we are going to be working on Lewis dot structures or electron dot formulas. And they're basically shorthand on describing the outside electrons and the orbitals by putting them around the elemental symbol, which sounds really complicated, but it's really simple. So if we remember that there are four main, let's go with neon. So there's four main, what do you call them? Oh, I gotta change the opacity. Sorry about this. That there are four electron orbitals in each shell around an atom. So if we were to take, let's say, neon, neon, we know that there's four orbitals. There's one orbital, there's another orbital, there's another orbital, and there's another orbital. And we're referring to the outside shell. But so if we were to take neon again, there's our nucleus. And remember, there's one orbital, there's another orbital, there's another orbital, and a fourth orbital. And then we also have the original two, the original orbital, the first shell, for hydrogen and helium. We know that there's two electrons that can fit in each orbital. So for neon, this is a noble gas, all the orbitals are full. All the electrons are full up. So we can put those around the element and you can then we could take those off, take the circles off, take the drawings of them, and just leave the dots. And the way we find out how many electrons we want to put around is we're going to be looking at the valence electrons on your periodic table. And the valence electrons at the top are of the periodic table are listed above the periodic table, and you would have the number above each group or family or each column. So you have valence electrons on the left, and it goes 1 above hydrogen, 2 above beryllium, 3 above boron, 4 above carbon, 5 above nitrogen, 6 above oxygen, 7 above fluorine, and then the full set of valence electrons, or the electrons on the outside that bond with everything else, above helium. So the electron dots, or the valence electrons are above the words the periodic table, and it says valence electrons on the left, and then you would have your, here's my very badly drawn periodic table with hydrogen over here, helium over here. So you would have 1, and you'd have 2, and you have 3, 4, 5, 6, 7, 8. 8 is supposed to be above helium, but I couldn't fit it all in. So if we then move on to our other stuff, and the next page, meaning the other stuff. Sorry. Um, we can see examples of the first 8 valence, the first 8 electrons from lithium to neon. So lithium has 1 valence electron in our periodic table. Beryllium has 2. Boron would have 3. Carbon would have 4. Nitrogen would have 5. Oxygen would have 6. Fluorine would have 7. and neon would have 8. So let's choose. Let's choose. So neon is already done there. But let's choose radon. So radon, you're going to find it on the periodic table. It's in the last group, which is the noble gases, which means that has 8. You want to basically put the electrons around. And the reason I don't put 2s together is because that'll help you with bonding. So you have, and each part of that is the orbitals. And when all of the orbitals are full, it's said that the octet, meaning 8, is met. Basically, it means that the octet is full, that the octets are full. And that's also called the octet rule. There's also the duet rule, which means that the duet rule basically means that there's 2. Octet means that there's 8. And it basically means that the electrons are full for that orbital, for that shell. So when all 4 of the orbitals are full, with all 8 of the electrons full, then the octet rule is complete. So you have to work on let's change. I wonder. No, I was hoping I'd be able to do that. I do, yes. Okay. So basically, you have to basically be working on sodium, and it's not letting me do that. So, but going back to the comments, drawing. Let's do area highlight. Okay. So you have to basically be working on sodium, cesium, calcium, strontium. Again, highlight. It's not letting me do that, so let me see what I can do. There's the highlight tool, and it's still not letting me do it. All right, well, did you ever have one of those days where things aren't working the way you want them to? Oh, that should work now. Okay. Or not. Okay. Uh, so so you're going to be working on strontium, aluminum. Let me get my little pen tool out again so I can. There we are. If I kept looking for it, I'd find it. All right, you're going to be looking at strontium, aluminum, gallium, silicon, germanium, phosphorus, antimony, selenium, polonium, bromine, astatine, neon, and radon. Neon is already done. That's about it. It looks hard. I've done one. If you need some help, please feel free to email or call me. And if you also need, if you, excuse me, if you aren't in my class, feel free to leave a comment below, and I will get back to you as quickly as possible. Thanks a lot, and have a sweet day. Bye now.